Hello and welcome to yet another South Korean College Scholastic Ability Test video. Today's problem is from the test that high school students took who went to college in 2012. The problem says, in coordinate space, triangle ABC satisfies the following conditions. Condition A says the area of triangle ABC is 6, and condition B says the projected area of triangle ABC onto YZ plane is 3. What is the maximum value of the projected area of triangle ABC onto plane x minus 2i plus 2z equals 1? Alright, so this is our problem, and if we schematically sketch the given information onto the coordinate space, it looks something like this. So we have triangle ABC here, whose area is fixed to 6. And we have YZ plane here, whose equation is actually just x equals 0. And the projected area of triangle ABC onto this plane is fixed to 3. These two fixed areas are our only constraints, and we want to know the maximum value of this area right here. The projected area onto plane x minus 2i plus 2z equals 1. Now I am going to explain some theoretical backgrounds required to solve this problem, in case some of you are unfamiliar with them. And of course we need to talk about projected areas, since that is the main topic of this problem. Suppose we have a flat shape on a certain plane whose area is A. Then we have the projection of this shape onto another plane, and the projected area is denoted as AP. Then two areas are related as follows. If the measure of the angle between two planes is theta, then AP is equal to A times cosine theta. And let me explain a bit more about this angle theta. The angle between two planes is called dihedral angle, which can be more strictly defined like this. We can think of a third plane that is perpendicular to the line of intersection between two given planes. This means that the black intersection line is perpendicular to any lines within that third plane. The dihedral angle is an angle formed on that third plane between these two lines that are both perpendicular to the black intersection line. But doing this work with pure geometry is often a hassle, so in coordinate geometry, we use normal vectors of planes. Suppose that two planes have normal vectors n1 and n2 respectively. Then the angle between two planes is simply the angle between two normal vectors n1 and n2. This angle can be obtained from the fact that we have two formulas for the dot product of vectors. The dot product of n1 and n2 can be calculated by either using magnitudes of two vectors and cosine theta, or using components of two vectors. Using these two formulas, we can easily obtain the value of cosine theta. Now let us apply this knowledge to actual problem. In our problem, there exist three different planes. The plane containing triangle ABC, YZ plane, and plane x minus 2i plus 2z equals 1. So we need to introduce three normal vectors. But instead of just normal vectors, let us introduce unit normal vectors, which are vectors of unit magnitudes. First, let us denote the unit normal vector of plane ABC as vector n, having components a, b, c. For the unit normal vector of YZ plane, I will call it vector L. And you can easily notice that vector L is given as 1, 0, 0, because that's the unit vector perpendicular to YZ plane. Lastly, as for the unit vector of plane x minus 2i plus 2z equals 1, let us use the notation vector p, and from the equation of the plane, we know that vector 1, negative 2, 2 is perpendicular to this plane, so we write 1, negative 2, 2, and divide this with the magnitude of this vector, which is 3. Now let us address some important conditions. First, let us address the area condition given in the problem. It says the original area of the triangle is 6, and the projected area onto YZ plane is 3. Here, let phi be the smaller angle between normal vectors of these planes, hence the angle between two planes. Then from the projected area formula, we have 3 equals 6 times cosine phi. Therefore, cosine phi equals 1/2. Here, let us use the two formulas to calculate the dot product n dot L. From the formula using the angle, we have magnitude of n times magnitude of L times cosine phi. And from the formula using components, we have vector a, b, c dot 1, 0, 0. Hence, a times 1 plus b times 0 plus c times 0. These two magnitudes are both 1, since they are unit vectors, and cosine phi equals 1/2, so we obtain a equals 1/2. This means that in our process of finding the maximum value of this triangle, the value of a is fixed to 1/2. So the value of a is determined, and now let's address the condition introduced by us, which is that n is a unit vector. This gives a relation between other two components b and c. The magnitude of n squared equals 1/2 squared plus b squared plus c squared, and this must equal 1 squared. Hence we obtain b squared plus c squared equals 3/4. And now let's finally obtain the expression for the projected area of triangle ABC onto plane x minus 2i plus 2z equals 1, which we will denote as AP. Now we need an angle between normal vectors n and p, and let's use theta for that angle. Then the projected area AP can be expressed as original area 6 times cosine theta. Here, cosine theta can be obtained by aforementioned formula related to the dot product, where the numerator is calculated using components. So we have vector 1/2, b, c dot 1/3 of vector 1, -2, 2, and both magnitudes are 1 since they are unit vectors. Therefore, AP, which equals 6 cosine theta, is expressed as, if we multiply 6 on this second vector, we have 1/2, b, c dot now 2, -4, 4, which gives 1 minus 4b plus 4c. So we have obtained this expression for AP. Also, we have this condition for B and C. Therefore, the main goal of this problem can be stated like this. We want to find the maximum value of 1 minus 4b plus 4c when b and c are constrained by the condition b squared plus c squared equals 3/4. And I will show you 3 different methods to do that. Yeah, not 1, not 2, but 3 methods. The first method is the simplest method if you know the special inequality called Cauchy-Schwarz inequality. The general Cauchy-Schwarz inequality is an inequality of vectors, but for this problem, this real number version is good enough. If we look at the expression for AP, we know that we need to maximize minus 4b plus 4c. So applying Cauchy-Schwarz inequality, minus 4b plus 4c squared is less than or equal to negative 4 squared plus 4 squared times b squared plus c squared. And this part is 3/4. So we have 32 times 3/4, which is 24. This gives minus 4b plus 4c is greater than or equal to negative 2 times square root of 6 and less than or equal to 2 times square root of 6. This suggests that the maximum value of AP is 1 plus 2 square root of 6. But is the equality possible? Well, the equality holds when the ratio negative 4 to b is equal to 4 to c, that is, when b is equal to minus c. And combining this with this b squared plus c squared equals 3/4, you can easily find out that this equality on the right holds when b equals negative square root of 6 over 4 and c equals square root of 6 over 4. Therefore, the projected area AP has maximum value of 1 plus 2 square root of 6 when the normal vector of plane ABC is 1 over 2, negative square root of 6 over 4, negative square root of 6 over 4. And from our multiple choices, the correct choice is choice 1. But we can think of another method to deal with this maximization part. And the second method is to think about the geometric interpretation of the given conditions. But what does it mean by geometric interpretation? Well, let's start from this condition. b squared plus c squared equals 3 over 4. Isn't this a familiar expression in terms of geometry? Yes, it is the equation of a circle, but on BC coordinate plane. More specifically, it is a circle centered at the origin having radius of square root of 3 over 2. What about AP equals 1 minus 4b plus 4c? Well, it is the equation of a straight line also on BC plane. Notice that 4c is equal to 4b plus AP minus 1. Therefore, c equals b plus AP minus 1 divided by 4. This is the straight line with slope 1 and c-intercept AP minus 1 over 4. Therefore, we have a straight line with fixed slope and varying intercept. And from the graph, you can easily notice that in order to maximize AP, we need to maximize the c-intercept. So, when does this intercept becomes maximum? Well, it is this case, right? When the line is tangent to the circle. That is, when b and c have values corresponding to this point right here. Let us find the value of AP, and since we have the line with slope 1, this can be done by easy geometry. So this length is radius square root of 3 over 2. So this length here is square root of 3 over 2 times square root of 2, which is square root of 6 over 2. So this intercept right here has value of square root of 6 over 2. So AP minus 1 over 4 equals square root of 6 over 2, which gives AP equals 2 square root of 6 plus 1. So this is the maximum value. Hence the correct choice is 1. Moreover, since this point right here is negative square root of 6 over 4, square root of 6 over 4, the normal vector of plane ABC at maximum condition is 1 over 2, negative square root of 6 over 4, square root of 6 over 4. We can think of another method, namely the trigonometric substitution. I have mentioned that we can think of b and c as coordinates of a point on a circle, and some of you may already know that the points on a circle can be also expressed using trigonometric functions. So getting straight to the point, let b equals square root of 3 over 2 times cosine alpha, and c equals square root of 3 over 2 times sine alpha. Then AP can be expressed as 1 minus 4 times square root of 3 over 2 cosine alpha plus 4 times square root of 3 over 2 sine alpha. So we can write 1 minus 2 square root of 3 times cosine alpha minus sine alpha. Notice that we have a linear combination of cosine alpha and sine alpha. This is a very good form to apply harmonic addition of trigonometric functions, which allows us to convert the given form into a single trigonometric function. So by applying this formula, we have AP equals 1 minus 2 square root of 3, then times square root of 2 times cosine alpha plus some phase shift delta. Actually, in this case, you can easily find that delta equals pi over 4, but that is not important here. Anyway, since the cosine term can have values from -1 to 1, we can also notice from here that the maximum value of AP is 1 plus 2 square root of 6. Hence the correct choice is choice 1. And that's all for today's video. Thank you for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.